Yeah, great. So we are in DevConf.CZ 2022. My name is Luca Berton, and with me there is Katerina, and we are the moderator of room number 2, the best one. And next up, we are expecting Christian and Ayesha for speaking about the state of OKD 4. It's written 4 in my...
It's version 4 of OKD in 2022. Yes, the state of OKD in 2022.
So the stage is yours. Enjoy.
Thank you, Luca. So welcome, everybody. I'm Christian Glombek. I'm a software engineer on OpenShift, in the OpenShift organization within Red Hat. And I've been one of the contributors to OKD. And this is my lovely colleague.
Hi, this is Ayesha Kaleem, and I work with the OpenShift customer-focused engineering team. And today I will be participating with Christian as a co-speaker in this presentation. And yeah.
Awesome. So welcome, everybody. Let's give you a quick look through the agenda. So we will be starting off today's presentation with a live installation, a live demo installation of a cluster on vSphere. Then we will be giving a high-level overview of OKD, what it is, how it works, what components it has, and so on. Then Ayesha will talk a bit more in detail about operators and the operator hub. Then we will talk about the state of current affairs in OKD, give a quick update on what's going on at the moment. Then we will plug to you the OKD and Fedora CoreOS working groups that you might want to join if you're interested in contributing to either of those projects. And in the end, we will have some time for Q&A. So with that, let's get started. I'll hand it back to Ayesha for the installation. And we will get started with that because it might take some time, and we will be returning to the installation as we go through the presentation later on.
Thanks, Christian. So yeah, let me just share my screen. And as Christian already described, that we're gonna start our presentation with the exciting demo where we would be installing the OKD cluster on VMware vSphere, and it will be a really simple and easy process where we will be just using the OKD 4.9 release for the installation. So everyone can see my screen. I hope it's everyone can see it.
Yes, we can see, and
okay.
We really appreciate your font.
Okay, thank you. So first of all, that I would be joining to my virtual machine to install the OKD cluster. So first of all, I'm going to download the OpenShift client, and my virtual machine is basically on Linux based, so I'm going to use the Linux based release. First of all, that I'm downloading the OpenShift client and then OpenShift install. So yeah, I have already downloaded it. So I will be using. So if I just wanted to here mention that if you have already OpenShift client installed, then you just need to use this OpenShift client command to install the OKD 4.9 release, which is a OC command, and it's really easy to directly download it and set up it. So so we have two files which we need to extract. So I have OpenShift and yeah, these are now extracted. These files are extracted, so I just need to move them to my binaries. And now we can see the version of OpenShift client, which is a client version 4.9 OKD, and also the version of OpenShift install. So yeah, that was quick and that was so easy to set up the OKD on your virtual machine using OKD release image. So now the real work has should be started, which is to create the OKD cluster on VMware vSphere. But for that, we need to first create the install config for OKD configurations on vSphere. Install config, basically we can use the OpenShift install create command to create the install config, and it's an interactive way to install the to create the install config. Otherwise, if you don't want then interactive way, then you can definitely create a install config.yaml file and put all of your configurations in it. But I'm trying to create it interactively. And also the install config file is actually dependent on the cloud provider. If you want to go for Azure or AWS or any other cloud provider, so it depends, the attributes in the install config depends on that cloud provider. So I'm using vSphere. So first of all, for the authentication, you need to select your public key and then select the platform, which is vSphere. And now I have to write my vCenter and username. Okay, so that's my password. And I need to select the data store. It can be your, it depends on your infrastructure of, and also the network you need to select. It also depends on your infrastructure, that what network you want to select, and for installing your cluster. So I'm just using the dev segment here and my virtual IP address. IP address for the ingress. Base domain, which is, in my case, is VMC dev cluster. And cluster name, whatever the name of cluster you can define. Like I can use my username for my cluster so that anyone can, of course, recognize that it's my cluster. And on for pull secret, you don't need a actual valid pull secret for OKD installation, as OKD's community thing, and it's, of course, it's available for everyone. So you just need a valid fake pull secret to write it down here. So the install config has been created along with that my directory, where I just need to create the cluster with my using my install config. So for that, I would be using that OpenShift install create cluster directory. I need to define the directory and log level. It can be log level can be info and debug. In debug, you will be debugging the basically installation and reading about each and every step. So here I'm using info and installing the cluster. And I need to mention one thing, like I have used my install config, which I have created by using the OpenShift install command. But if you want, you can add edit your once your install config file will be created, which will be in the directory of my name, which is Kaleem. And then if you see in the directory, it will be install config, which I actually forgot to mention. But so in install config, you can add or edit multiple more configurations if you want, because the configurations, the interactively you have seen the username and password and all, they are the basic configurations for installing the OKD cluster on VMware vSphere. But if you want to add multiple more configurations, you can definitely edit your install config file to add more configurations, because we have some optional attributes as well. For example, you can enable disk provisioning for vSphere, thin disk provisioning, what kind of disk provisioning you want to use. So there are many more. So that's it from my side, and I think this installation will take some time. And once and we will get back to our installation by the end of the presentation. So I would pass the mic to Christian to continue with it. Thanks, everyone.
Perfect. Thank you, Ayesha. We've had some questions coming up in the chat in the meantime. Maybe we can quickly tackle them as we go through. I think we have enough time.
Yeah.
So the question of what are the minimal permissions at vSphere on the vSphere side to do this, and also on the Azure side. I'm not an Azure or vSphere expert, but maybe you know what you have to set up. There is definitely extensive documentation on what to do before in preparation for doing this, but I'm not aware of what steps concretely. Maybe you know, Ayesha. I don't want to put you on the spot, because we have people doing that for us, usually preparing the infrastructure.
Yeah. For vSphere, actually, you need to define the permissions and everything when you are creating your virtual machine and your infrastructure. So for the permissions, I think you are not supposed to mention it in the install config or during the cluster installation. I think you need to define it in your basically when you are creating your infrastructure on vSphere. Yeah.
Yeah, I agree. There we have the docs.okd.io page, and I think because that is essentially the same documentation as OpenShift, the product has it, and I think you should be able to find some info on the install prerequisites there. All right, I think we can move on and really get started with the presentation now. What is it that we've been talking about here? What is OKD? And well, we've just done that. Okay, so the overview. What is OKD, and why is this important? Why should you care? So OKD is a community distribution of Kubernetes. It is the community distribution of OpenShift. And OpenShift is obviously a distribution of Kubernetes that Red Hat ships. So in OKD, we have the OpenShift code base for the cluster side of things, for all things that run in containers. And then we have Fedora CoreOS as the base operating system this works on. The important distinction that OKD can make is that it ties together the life cycle of the containers on the cluster itself and the operating system. It's very tightly integrated, and operating system updates are shipped to the cluster as a container image and then unpacked onto disk by an operator on the cluster, and then the nodes are rebooted one after the other, meaning that the cluster actually manages the node host upgrades itself. And it's just a one-click thing. You click on a button and it will update your operating systems on all the nodes and the cluster code, meaning the operators that run your workloads. So a lot of words right here. We will try to put it a little bit more into perspective on this slide. So starting from down below, from the bottom, we essentially have an infrastructure, and it can be any infrastructure. In the demo, we've just shown you it is vSphere, but we also support other providers such Google, Amazon, Azure, you can name them, bare metal, overt, OpenStack, and more. As long as you can get a Fedora CoreOS image on that platform, you can essentially install OKD. You can even overwrite that boot image in the installer that's used by the installer by default. So, and with that, we have our host operating system, and in OKD, that is Fedora CoreOS. So Fedora CoreOS is an operating system optimized to run containerized workloads. And this is what all of this is about. This is about running containerized workloads on a Kubernetes cluster. Kubernetes, for people that haven't heard about it too much, Kubernetes is a distributed platform for running containerized workloads. Fedora CoreOS, as a standalone thing, is already optimized to run containers, and we take it one step further, and make it optimize it even further for the Kubernetes use case, for the cluster use case, where you have multiple hosts in a cluster. And Fedora CoreOS is based on, I would say, 2 key technologies. It might be 3 key technologies. RPMs, the package management we use for Fedora and also for RHEL. OSTree, which is essentially like Git for your operating systems, meaning you have a commit in a OSTree repository associated with the state of your disk, with the contents of your disk, and you can move from one commit to the next transactionally and update or layer on top new commits or rebase to another commit, thereby switching out the host OS version in a very transactional way. And also, it is image based. You essentially download a commit from an OSTree repository, put it onto disk, and that commit isn't changeable. You can only write on top of it on an overlay, essentially. And we don't make most of the disk writable in Fedora CoreOS either. So this is the base image technology. RPM-OSTree ties together RPMs and OSTree. You may know OSTrees also from the Flatpak use case. Flatpak also uses OSTrees. For the first boot configuration, we have another very important tool in OKD and in Fedora CoreOS, which is Ignition. This is a tool that you can pass configuration to, and that configuration declaratively describes the state of your OS that you want to get. It is a bit like Cloud Init, but more declarative. And I would say more powerful. You can almost do anything with it. And the way it works is you pass the configuration on the very first boot, and then it loads the operating system into the init RAM-FS, into your memory. And then it runs in the memory before even writing anything to your disk. It'll prepare the operating system that you want to get, that you have configured with this configuration. It'll prepare that in the init RAM-FS, then write to disk and reboot into that newly written OS on the disk, putting you right where you want to be, right on the first boot. And that is very powerful, and we use it also for continuous machine configuration during the cluster's life. At the very beginning, you can configure almost anything with Ignition, and then later on, after the installation, we don't support, for example, resizing the disks while the cluster is already running, or reformatting the disks. There's only a subset of functionality available later to manage, For example, you can still write files and systemd units with ignition later on, but there's some configuration that can't be changed in the OKD use case after the initial installation. And then we come moving up to the Kubernetes layer here. So Kubernetes is a distributed container platform, and that means it runs on top of Fedora CoreOS here, and it talks to other Kubernetes nodes using a distributed data store etcd to find out what workload it must run, what the state of the cluster is. And we have automated this platform from top to bottom. We have a programming pattern called the operator pattern, and we're using that extensively to automate all the things that you would usually on a vanilla Kubernetes cluster would have to set up manually. I see the sound might be not good. Okay, I'm very sorry about the audio if that doesn't come through.
It's
so on the cluster side,
I think. Yeah. Yeah, we can understand. Sorry,
okay.
go on.
Oh, I'm very sorry. I don't get a feedback here on how my audio works, unfortunately. Okay. Okay, so we use operators to automate the operation of the cluster through and through, meaning the intervention that has to be done by a human is kept to minimal level. And we have operators for all kinds of core parts of the cluster, networking, the internal registry, and so on. Ayesha will talk about that more in a second. So this is our cluster side, which is essentially the turnkey ready solution of a cluster that you get with OKD. And then on top of that, you can deploy your own workloads, applications and services. And those applications and services might be other operators that will facilitate or automate another part of your infrastructure, like storage or anything really. There is a cert manager operator. There's a DNS external DNS operator. So a lot of operators you can use to then enable more productivity, essentially, by having that manage a resource type for you. But it doesn't have to be an operator. You can just deploy any Kubernetes resource on top of OpenShift, and it will run. And if it's an operator, the operator will know how to reconcile against the state it wants to be in, and will do something more. That is what the cluster itself will also be doing. As part of the core payload, and I will talk about that more, we have the operator lifecycle manager, which is essentially an operator for managing optional operators that you can install on top. So yeah, a lot of things going on in the architecture here, but I do hope this has given you a slight impression of how it's built up. And I think with that, I will hand it back to Ayesha.
Thanks, Christian. So as Christian mentioned about operators a bit, and I will be dig deeper into it a little bit more. But first of all, before talking about operators for OKD, I want to talk about what operators are. In simple words, operator automates what Kubernetes does on behalf of a user. Operator extends the Kubernetes functionality to automate the management of the entire lifecycle of a particular application. It's a custom Kubernetes controller that uses custom resources to manage applications and its components. And here, Operator SDK is basically provides you a framework to build your operator using different technologies, whether it is Golang, Helm, or Ansible. So Operator SDK is kind of a template or a framework where you can build your own operator. For the next slide, I'm gonna be discussing about operators for the OKD cluster and for OpenShift. So OpenShift has been built leveraging the operators, which manages the application, but the cluster itself. For example, establishing a cluster on autopilot, where a cluster is managing itself by using the following operators. Christian, can you make it to the next slide? Yeah, thank you. So here, all the operators that OpenShift is using to automate their OpenShift OKD clusters. First of all, that the main operator is cluster version operator. It's basically make sure that all essential operators are present, which I'm going to discuss in this slide. Cluster version operator also maintains and updates the versions of the core operators, and it's basically the main operators for the OpenShift cluster. So in the core operators, the etc kube API server, kube controller, a manager, kube scheduler, and these are the operators that ensures the core components of Kubernetes are configured for a cluster. And the next one is network and ingress, and they are worth mentioning. The cluster network operator installs and upgrades the networking components on an OpenShift Kubernetes cluster. It follows the controller pattern. It reconciles the state of a cluster against a desired configuration, which includes ensuring if the CNI plugins are installed and SDN is configured. In OpenShift, the cluster network operator runs very early in the install process, while the Bootstrap API server is still running. An OpenShift ingress operator is an OpenShift component which enables external access to the cluster services by configuring ingress controllers and ensures if the routes are set up. Ingress operator implements the OpenShift ingress controller API for the OpenShift OKD cluster. And the next one is image registry operator. It manages all configuration of OpenShift registry, including creating storages. On initial startup, the operator will create a default image registry resource instance based on configuration detected in a cluster. For example, what cloud storage type to use based on what cloud provider. If insufficient information is available to define a complete image registry resource, the incomplete resource will be defined, and the operator will update the resource status with information about what is missing and what needs to be defined and what is missing. So, and the cluster monitoring operator manages and updates the Prometheus-based cluster monitoring stack deployed on the top of OpenShift cluster. So yeah, that's all about the operators, that how they are basically working for OpenShift OKD cluster and how OpenShift is leveraging them. In the next slide, I'm going to be discussing about OperatorHub.io. And OperatorHub.io is a new home for the Kubernetes community to share operators. And in this slide, there is the operator lifecycle manager, which is worth mentioning. OLM, aka OLM, is like a cluster version operator for all the operator hubs or optional operators, because in operator hub there are tons of operators which you can use to automate the life cycle of your cluster. So and OLM basically works for as a cluster version operator for them. Basically what it does, it helps users to install, update, and manage the lifecycle of Kubernetes operators, and it takes care of operator scope. Just cluster-wide or namespace only, ensures it can be updated manually, and manages permissions to use and install operators for the OpenShift cluster. Operator Hub is integrated in OpenShift console, so developers can install operators via self-service interface. For example, storage operators based on Rook.io, pipeline operators based on Tecton, Argo CD, KubeWord, Grafana, and many more. So yeah, that's all about operators on Operator Hub, and I have discussed about the core operators that works for the OpenShift OKD cluster, and the optional operators that makes the life cycle of cluster far more easy and automates it as much as you want. So I will be giving mic back to the Christian to talk further about the OKD and the state of OKD. So yeah.
Thank you, Ayesha. I hope my audio is a bit better now. I've switched the microphone. Let me know in the chat.
Not actually. I still feel noise in your, yeah.
Worse?
Not worse, but it's better, but it's still a little bit of noise, yeah. I think you can carry on.
It's weird because I hear your voice garbled a little bit too. I have a gigabit connection here, and can't be
you should continue.
bandwidth, I think.
Yeah, because it's not that bad. You can continue.
Yeah. All right. Okay, let's continue then. So a quick status update, essentially, on OKD for those of you that have been following it for a bit. We are currently at a stable version 4.9, and we have in the recent months introduced two sub-working groups have introduced themselves and have started work. So there's the very active and frequently meeting documentation sub-working group that focuses on improving the OKD documentation. As some of you may know, we share the same sources for our documentation with the OCP OpenShift product, but oftentimes, obviously, things will point to an OpenShift Compute Platform product specific thing, and that'll then also show up in OKD. And some things also might not apply to OKD that do apply to OCP. So I will try to turn off my video. Maybe that helps. Let me know if it's better now. So yes, if you're interested in helping or just checking out what the documentation sub-working group is doing, check out the OKD calendar, which I will link to later on. Okay, it's somewhat better. That's good. Awesome. Then we have the newly created virtualization sub-working group, which focuses on getting the hyper-converged experience really to an excellent level in OKD. And with hyper-converged, this means essentially running virtual machines in Kubernetes containers or in containers on Kubernetes on OKD. And that's a different model than, for example, the other way around, which would be deploying OKD on top of OpenStack. You can now manage virtual machines with Kubernetes with the hyper-converged operator. So there's a lot of work going into that right now to make that a great experience. If you're interested in that, feel free to join that working group for updates. Then, just very currently, we are now testing OKD with C run instead of run C, which is the underlying container engine that is used for running the containers. And C run is a replacement for run C, and we now have the ability to test that. And you can probably already switch to using that with a configuration change. Another very important switch that we made is we are now installing with C groups v2 by default. I think, Vadim, if I say anything incorrectly, please do correct me in the chat. But I think C groups v2 is now the default. You can switch back to v1, and old clusters using v1, I think, won't be updated. to automatically switch to cgroups v2. And then we've talked a lot about operators, and currently the only catalog source that is enabled in OKD is the community catalog. Some operators are missing from the community catalog. We are aware of that, and we are now working on a second catalog source specifically for OKD operators, which is operators that might have been previously part of the OpenShift core that were moved out into an optional component that we don't currently distribute with OKD anymore. Those will be put there. And other Red Hat released operators that don't currently have a working release in the upstream catalog, at least not working on OKD, because operators might need to be adapted to OKD to really integrate well. Usually you should be able to run all the upstream operators, for example, Rook.io for storage, and Istio for service mesh and stuff like that. But we do have the ability to integrate that even more tightly. And currently those operators aren't really released for OKD. You can obviously build them yourself, but I doubt anybody that really does that or has automated that process themselves. So we are trying to do that now with this new OKD operator catalog, which is coming soon and will hopefully make the experience of our users on OKD even better. And then another coming soon, we will get OKD for ARM64. And this has been in the making for some time. We do have ARM64 builds of most things, but we still have to set up some automation on our build system side for all of that to be bundled together. So we now have Fedora CoreOS being released for ARM64. We have our downstream build system building images for ARM. We are currently working on getting our upstream build system, which is Prow, which is the system that creates OKD releases, and it also does CI testing for OpenShift, the whole of OpenShift, both the product and OKD. And we're currently working on getting that build system ready to build our containers. Once that is done and we have a working release, obviously, or a working version, we will obviously bundle that up as a release for ARM as well. So coming soon. And yeah, the next agenda item is just my plug of the 2 working groups that are deeply involved in this effort. So OKD has a working group which meets in a video meeting every 2 weeks. There is a calendar, and I'll show the link in a second. And did I just say OKD? The OKD working group meets in a video meeting every 2 weeks, and the Fedora working group, Fedora CoreOS working group, meets on IRC or Matrix once a week in a chat meeting. The OKD working group, you can find us on Slack for user-related questions. Use the OpenShift users channel. If you have a technical issue, then you may open a ticket, an issue on the github.com/OpenShift/OKD repository. If you have usage questions and still want to use GitHub, please don't open an issue, open a discussion. If it turns out to be an issue, we will convert it. Otherwise, we will have to convert it from an issue to a discussion. So please make sure if you have just the usage-related questions, open a discussion. And the calendar, if you want to subscribe to that calendar, you can import it from the Fedora calendar project, which is apps.fedoraproject.org/calendar/OKD. You can subscribe to the OKD and also the Fedora CoreOS calendars there and get them on your own calendar in case you want to meet. And you're very welcome to join the meetings. They are very casual. We usually give an engineering update and then talk about current things. We have a very friendly community, I would say, and we always try to make things better and improve on the current problems we're facing. So yeah, that's the OKD Working Group. Really, if you're interested, come by and say hello. Even if it's just that, it's nice to see new faces there. And the FCOS, aka Fedora CoreOS Working Group, they have their own channel on IRC, and also you can also use Matrix if you're already on the new Matrix server that is hosted by Fedora, and you can actually use any Matrix account to connect. And they also have an issue tracker, which is github.com/CoreOS/Fedora CoreOS tracker. And if you find any issues relating to the host operating system, then that's the right place to open the bug. If you aren't sure, you can always just open a bug in either case, and we will triage it as best as we can and send it off to the right people, to the right team to take a look at. It's sometimes not easy to see what component is affecting an issue. So if you provide some logs, we will have a look, and then we will usually send you off to Bugzilla to open a bug for that specific component. If you already know that process, it's very helpful for us, obviously, for you to go directly to Bugzilla and don't go through the GitHub step. If you're issues opened on Bugzilla are really the ones that are being worked on. So it's always best to have one there. If you're not sure, though, the GitHub repositories are a great place to find more information. And there's also a calendar you can subscribe to, and the weekly IRC chat meetings will show up on the CoreOS calendar for you. Also, a very friendly community, I would say, and they're always welcoming to new folks. So, and I think we are perfectly on time, 45 minutes. I don't know what the state of the cluster installation is, so I will pass it back to Ayesha to have a look at that before we start off the Q&A.
Yeah, thank you so much, Christian. Our cluster has been just installed on VMware vSphere, and you can see the cluster here. There are 3 master nodes, which are, of course, they are based on Fedora CoreOS, and 3 master nodes and 3 worker nodes for the OKD cluster. And definitely you can access them if you want. And so yeah, you can access them, and I will be just destroying the cluster because of course you can access them and run on your application on it, but I would be just also before that, I would be before destroying the cluster, I wanted to show you. So there are also our ignition files and the meta files, all the files of the configuration of the cluster. So once you delete the cluster, all the files will be deleted, and of course your install config file will also be deleted. So I'm just need to destroy the cluster. I think. So yeah, it will take a few minutes, and meanwhile we are open for the questions. and the cluster will be destroyed. Yeah.
Awesome. I think everybody would have seen now that it is really super easy to install an OKD cluster. It's just a few steps on the TUI tool that we have. And you obviously, as Ayesha explained, you can also edit the install config that is generated before actually kicking off the installation to customize any aspect of the cluster if you have special requirements for it.
Christian, you can turn off your camera for a better voice.
You want to fix this on the host. Oh yeah, I will turn off my camera again. Weird. Okay. Yeah, I do hope that you can hear me now better. So.
Yeah, slightly better.
Yeah, it's really super easy to install an OKD cluster, and I think we got that across. Yeah, I think with that we can pivot to taking questions now. I think there was one I saw on the chat, or it was more of a statement. So we are talking about enterprise-grade ARM systems, and that definitely ARM will be requiring not necessarily enterprise-grade, but it will be requiring UE5 support, which is essentially the SBBR certification by ARM. I think so. That's the server certification, and that means you don't need a custom device tree to boot your device. But on the other hand, that kind of firmware is already available for the Raspberry Pi, for example. So obviously, right now we have a requirement of 16 gigabytes of RAM, but we might be able to cut that down in the future. Or Raspberry Pi will release a version of their hardware with 16 gigabytes of memory, and then we should essentially be ready to deploy OpenShift on that, or OKD in this case. Okay. Do we have any other questions? Okay, I will read them out. What kind of virtual load balancer did you use on this VMware deployment of cluster? Ayesha,
yeah. Well, I'm not exactly sure, but I think HA proxy. But I'm not exactly sure for this. Yeah.
Oh, yeah, I think HA proxies are default, and that is probably what we used in this.
Yeah.
Yeah. Thanks, Vadim, for putting in your answers in chat as well. I appreciate that. So how good is OKD for data science? Is it as good as OpenShift? Essentially, OKD is OpenShift, as Vadim also said. It's exactly the same cluster code. Well, not exactly the same build, but it's the same code, a different build of that same code. And anything that works on OCP on OpenShift is expected to also work on OKD. So if you have any kind of operator or Open Data Hub, for example, for data science, then that is also ready to be deployed on OKD. Let's see if there's more questions. I will scroll up a little bit and see if I missed anything.
I think we are on time.
Yes, guys, you are perfect on time. You are doing so good. I saw a very vibrant chat during this session. So
yeah, we just want to share that if anyone wants to connect us via Twitter, you guys can connect us. And if you have any questions and want to ask, you can also contact us on Twitter. And if you Christian, yeah. So I think that's the thing. And in this presentation, by the end of this presentation, we have mentioned our Twitter names. So you, if the presentation is available, so of course you can contact us. I think Christian is not here anymore. So, okay, so thank you so much for all of your attention and listening us. Thank you so much.